Okay, hi everybody. This is going to be our first video for Chapter 6, and we are going to learn how to solve linear systems by graphing. Okay, so the first thing we need to know is what is a system? I know linear means line. Okay, a system is a set of two or more equations with the same variables. Okay, for example, right here, there's the first equation. The variables are x and y. The second equation has variables x and y. So we usually put this little squiggle, okay? You'll get good at drawing that. Two equations with two variables. Okay? You could have more than that. You could have three equations with three variables, but we're going to start off mostly with just two. Okay? A solution to a linear system. A solution is an ordered pair of numbers that satisfies both equations. Okay, so for example, maybe we have the ordered pair 2, 3. Okay, so we're talking about a point, right? We're talking about a point. And this ordered pair, this would be the x and this would be the y. Okay, so when you solve an equation, you usually find the value of the variable. If there's two variables, we have to find two numbers. One for x, one for y. And we're going to put them together like a point because they go together. Okay, so let's just get good at determining whether or not it is. Tell whether this ordered pair is or is not a solution. Okay, so it has to work. These are both lines, linear system. It has to work in both. Okay, so 4 is the x number and 1 is the y number. Okay, so I'm going to check this first equation right here. So give me an x. 4 plus 2 times the y number. That would be 1. So 2 times 1. And does that equal 6? Okay, so we're checking. 4 plus 2 equals 6. Yes, it works. Okay, so it works in equation 1. So do I really have to check equation 2? Absolutely. You have to check both equations, okay, because it has to work in both of them, not just one of them. So 4, 1 is a solution for the first equation. Now let's check the second equation. Okay, 3 times the x number. So 3 times the x number is 4. Let's make sure we use parentheses because I don't want it to look like the number 34. Plus the y number. So plus 1. And does that equal 11? Okay, 3 times 4, 12 plus 1 more. Wait, that does not equal 11. Okay, so I'm going to slash that out. That means does not equal. Okay, not equal. It is not a solution to the system. 4, 1 only worked in one of the equations, not both of the equations. So it's not a solution for the system. Okay, do you have to check both? Yes, absolutely. Okay, number 2, let's check this point. 5 times the x number. So 5 times -2 minus 2 times the y number. So my y number is 1. Let's see if that makes -12. -10 minus 2. Does that equal -12? You can go ahead and subtract two negatives, or you can use your calculator. -12 does equal -12. So can I stop, or do I have to keep going? Yep, you have to keep going. Okay, I have to check the next equation. Let's check the second equation now. Tell me the x number. -2 plus 3 times the y number. Let's put 1 in place of that y variable. -2 plus 3. Does that equal a positive 1? Yes, 1 does equal 1. That is a solution because the point worked in both of the equations. It was a solution for the first equation and the second equation, so that is a solution for the system. All right, let's keep going. The next one we'll try is this point in this system. -3 times the x number, 4, plus 2 times the y number, which is -3. Does that equal -18? Please do this calculation and either say equals or not equals. Go ahead and do the work, please. Okay, what'd you get? Did you get negative 18? Okay, that is a solution. Do we have to keep going? Yes, of course, we have to try the second equation because it has to work in both. Okay, so now we have to try the first one. What if it doesn't work in the first equation? Do we have to keep going? No, because if it's not a solution for the first equation, then it's a goner. Okay. All right, we have to keep going here. 6 times x minus the y number, which is negative 3. Hey, do you guys know what minus a negative is? Minus minus makes a positive. Very good. Okay, does that equal 27? Go ahead and do the work. I need to know if it equals or not equals. 24 plus 3 more. It does work. It worked in the top equation and the bottom equation. So it is a solution for the system. The system is the set, or all of my equations. Okay, so that's how you check to see if something is a solution. Okay, we're going to be finding lots of solutions, and then I want you to check them so you can get an A on this first test with me. All right, let's use a graph to solve the system. Okay, so hopefully you guys just studied how to graph y equals mx plus b. Okay, so how do you solve, or how do you graph lines? Okay, so here's the steps. Let's just write them down. The first step, okay, is to graph line 1. All right, let's go ahead and graph line 1. Do you use the m or the b first? That's right, use the b. The y-intercept is 2, so I'm going to go up to 1, 2, put a dot. Okay, and the m is negative 1/2. So down 1 over 2, down 1 over 2, down 1 over 2. Okay, I want you to keep going till you run out of graph paper. When we solve a system with graphing, our graph has to be perfect. Okay, I'm also going to go to the left, up 1, left 2, up 1, left 2. I need to find the point. Okay, not all the points on this line, but which point do they both share? Okay, so I need to make sure that these points are perfect. Let's go as far as we can. Go all the way to the edge of the graph paper. Don't forget your arrows, because lines never end. Okay, all right, the second step, okay, would be to graph line number 2. Okay, so I'm going to use a different color here. Let's graph line number 2. Y equals mx plus b. So you're going to start with the b with the y-intercept. This time it's negative 2. Okay, negative 2. And now we're going to go ahead and use the slope, which is up 3 over 2. Up 3 over 2. Look at that. Look at that. They both have that point. Keep going. Up 3 over 2. Up 3 over 2. Down 3 over 2. Down 3 over 2. Okay, so here is line number 2. This line is going uphill. Okay, so I graphed my 2 lines. These 2 lines do have a point in common. Okay, step 3 would be to find the point. Find the point that works in both equations. So do you see the point that works in both of the equations? Okay, the solution is the ordered pair, so we need to have an x number and a y number, okay, that works in both of them, and I see it, it's right there. Okay, so it's the point 2 comma 1. The point 2 comma 1, there's the x number and there's the y number. That works in both of them. Okay, let's go to number 2. Step 1 is to graph line number 1. If you see no number here, the invisible number is 1. Okay, y equals mx plus b. The number in front of x, is a 1, and the b is negative 7. Okay, so negative 7 is where we'll start. 2, 3, 4, 5, 6, 7. There's the starting point, and the slope is 1. So we're going to go up 1, over 1, up 1, over 1, up 1, over 1. Okay, I'm going to go as far as the graph paper will allow because I need this graph to be perfect. when you're solving a system with graphing, the points have to be exact because you have to find the exact point where they meet. Okay, remember step number 2 was to graph the second line. Okay, so let's go ahead and graph our second line, starting with the b. Okay, here's the m, here's the b. The y-intercept is -2. Okay, we're going to go down 1 over 4. Down 1 over 1, 2, 3, 4. Down 1 over 1, 2, 3, 4. I'm going to go up 1, 1, 2, 3, 4. Did I find where they meet? Yes, they're both right there. They're both meeting in that point. So I'm going to go ahead and graph the lines. I see the point they both share. Okay, so when you're graphing lines, make sure you use your slope up and over till you see them meet. And the solution to this system, the point that they share is right there. Okay, and we make sure you use parentheses for a point. 1, 2, 3, 4 to the right, and 1, 2, 3 down. So 4, -3 is the solution graphically to the system of equations. Okay. All right. Sometimes when you're solving by graphing, okay, you have a system of equations, 2 equations, but they're not ready to be graphed. Okay, remember what we have to do to these? Okay, we have to rearrange them. So let's go ahead and start with line number 1. And it's almost y equals mx plus b, except the 2x needs to switch sides. And remember, when you switch sides, you switch signs. So positive 2x on the other side of the equal sign will be a negative 2x. So y equals, when you switch sides, you switch signs, negative 2x minus 1. Okay, let's rearrange equation number 2 because that one is not ready to be graphed yet either. Okay, so I'm going to use this workspace over here. I'm going to rewrite the equation. And the first thing I'll do is move the negative x to the other side. Some people like to say I'm going to add x, I'm going to add x. Okay, they like to do the work. However you do this, 2y equals mx plus b. I'm going to put the x first and then the number second. So that's my mx and then that's the b. Let's go ahead and divide all of them by 2. So y equals, what invisible numbers here? 1/2 x plus 4. Okay, so equation number 2 in rearranged form is y equals 1/2 x plus 4. Okay, now we're supposed to use graphing. Okay, here's the system, and then here's the new system that's ready to be graphed. Okay, let's go ahead and graph equation number 1. Y equals mx plus b. So we've got m and b. We'll start with the -1 for the b. And the m is -2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1. Let's do some going the other way. Up 2, left 1, up 2, left 1. Does it make sense the line is going downhill when the slope is negative? Absolutely. Okay. Let's see if this is enough dots. I could always add more points to see where they meet. Okay. Don't forget to put the arrows. Lines go forever. Okay, that is line number 1. Now we're going to graph line number 2. In this chapter, you're going to be graphing 2 lines at the same time. And they both have to come out perfect to find that special point. Let's start with a y-intercept of 4. And we're going to go up 1 over 2. Up 1 over 2. I think the point is going to be this way. So I'm gonna start going down 1, left 2. There it is. I found the point that is on both of the lines. Down 1 over 2. Okay. Once you find the place where they intersect, you have your solution. Don't forget to finish drawing the line though with the arrows. Okay. You have to draw 2 lines for the system to be graphed. Okay, and the solution to the system is the point right there. You don't have to draw this arrow. I'm just helping you find it. To the left and 1, 2, 3 up. -2, 3. Okay, when I say solution, that means this point is going to work in both of those equations. And you could check if you want to get an A. You could plug -2 for the x, 3 for the y. Do you think it's going to work in that first equation? Yes, it should. And it should work in that one. And if it works in both of them, then you got it perfect. Okay, so we're going to practice checking our solutions too. All right, and the last one here, where we're going to practice rearranging a little bit. Okay, so let's go ahead and rearrange equation number 1. I think it would be easiest if we just switch sides and switch signs since the y is already alone. Y equals the -x becomes a positive x plus 5. Let's go ahead and rearrange number 2. Since the y is alone, if I just move that 2x to the other side, y would equal -2x plus 8. If you don't like switching sides, then you're going to have to come over here, and this is what you would do. Okay, I'm not sure how you guys are doing this or what you prefer, but they're both good. If I subtract 2x from the left, I would have to subtract 2x from the right. So now the y is alone, y equals, and which one should I put first to be in that nice graphing form? Y equals mx plus the b number 8. Okay, either way you get the same equation. So whatever method you prefer is okay with me. But now it's time to go ahead and graph these. Okay, so let's graph the first equation. It looks like it's going to be an uphill line, and the slope is going to be 1 over 1. Let's start at 5, and we're going to go up 1 over 1, up 1 over 1, up 1 over 1. I'm not sure if this is where the solution is going to be. I'm going to graph some points to the left as well. Down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. You definitely want to make sure when you're doing graphing and you're trying to find a solution that you have all your points. So after I do this, if my lines don't touch, I'm going to have to go make some more points because you have to find the point exactly. So if I need to go back and add some more later, okay, that is a good idea because this point has to be perfect. The second line starts at 8. 5, 6, 7, 8, okay? But it's going to be a downhill line. The slope is -2 over 1. All right, down 2 over 1. Hey, look at that. Okay, that's my special point. I found it. Let's keep going a little bit more. Down 2 over 1, just so that my line can be drawn nice and straight. Okay, but I definitely see the point that they share. The solution is the ordered pair or point that they have in common. Okay, and so the point right there is 1, 6. Okay, 1, 6. If you ever start drawing lines, okay, here's just a little example. Let's pretend I drew a line, point, 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 and I drew my line like this. Okay, and then I have my other line like this, point, 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 and then I draw it. Okay, I want to make sure I find this point exactly. So down 2 over 1, down 2 over 1, until you actually get the point. Okay, don't let your lines start to go crooked and just estimate where they crisscross. Make sure you find that exact point. All right, we got one more page here, and we're going to work on telling me how to solve things. Okay, so we're going to write out the steps that we would use to solve this problem, and we're going to make sure that we have as many vocabulary words as possible. Okay, of course, don't forget to use complete sentences and some nice punctuation. Okay, so what would be the first thing that we would do? I don't think I'm ready to graph this yet, okay, because it's not ready. Okay, so here's the system, and what I would need to do is move the -5x over, and it would be y equals 5x plus 0. Okay? So step number 1. So first, what did I do? I know I put it to the other side, but we're going to try to find some math vocabulary words. First, rearrange the equation into, what form is this with the m and the b? This is the slope, and that's the intercept. This is called slope-intercept form. Okay. All right, let's go back to our work. We'll do some work and then we'll say what we did. Okay, would I be ready to start graphing yet? No, okay, because I have to get this equation ready for graphing. We're going to switch sides and switch signs as well. Y equals negative 5x plus 10. Okay, so what happens next? Rearrange the second equation into slope-intercept form, okay, as well, into slope-intercept form. Okay, so we got equation 1 ready to graph, we got equation 2 ready to graph. I think we're ready to graph. Okay, so let's go ahead and graph the first equation, slope-intercept. We start at 0, the origin. We go up 5 over 1, up 5 over 1. I'm going to go ahead and graph all 2 of those points since it's so few. Down 5 left 1, down 5 left 1, all the way to the edge of my graph paper. Now that's not a line. Okay, you have to actually connect the dots with a nice straight edge and put arrows. Okay, that is the first line. But that's not the system, that's just one of them. To graph the system, you have to graph both of them. Let's start at 10. And the slope is negative 5, so down 5 over 1. Oh, winner, winner, right there. That's my point. Down 5 over 1, down 5 over 1, down 5 over 1. Okay, there's my 2 lines. Well, it's not really a line until we finish graphing it with the straight edge and the arrows. Okay, what was the third step? Okay. Graph the system. Graph the system by using the slopes, and the y-intercepts. Okay, so we graphed both equations, and that's the system. Okay, and after you graph both of them, okay, you have to find the point where they intersect. Okay, find the point. And by point, that's the point they share. Find the point, or we could say solution. Solution, find the point that both lines share. Okay, so I found the point, and we're going to state the solution as 1, 5. 1, 5, okay? And finally, I'm going to conclude by the solution to the system is the ordered pair 1, 5. And that means that it works in both of the lines. Okay, great job, everybody.